Welcome back. We had been talking about measurements in epidemiology, and earlier we have been talking about two different kinds of measurements of occurrence and associations. And we ended last lecture where we talked about, first of all, prevalence, then we talked about incidence, when we talked about age specific incidence of asthma, and then we showed the need for conducting age standardization. Then we started a little bit about age standardizations and what are some of the principles. So in this presentation, I'm going to now finish off with where I kind of somewhat abruptly ended in the last lecture and continue with the more details. In the previous lecture, we talked about that if you can get age specific incidence or age specific prevalence from there, you can, by using a standard population, can get standardized rates. So I'm going to elaborate on that a little bit more on this one. So what happens is that we start with each specific rates in, say, in this particular case, two different populations, but you can make comparisons with any number of populations. So if you train your focus on the left hand side of the graph or of the presentation of the slide deck, you can see that in this slide on the left hand side we have a table that has got 11 rows and 6 columns. The first column shows age group labeled as age GRP, and it has got age groups grouped in the form of like 0 to 5 years, 5 to 9 years, 8 to 14 years, and so on and so forth. And then in the second column, we have got asthma in population 1, asthma in population 2. What is new about this table is in the fourth column, we have a column named as standard underscore population, which is a standard population, and that lists the number of individuals in each of the age bands that we have listed for the incidence of asthma in population 1, population 2. So this standard population, imagine this, that this standard population has a particular age specific number of people in them. Now, what we're doing is we are taking the incidence in the first population of asthma, i.e., the numbers in the column asthma underscore 1, then we are multiplying it with 100. And then what we are doing is we are dividing it by 1000 because we want to present that number in the form of per 1000 person years. This results in the fifth column, which is labeled as STD POP1, which is standardized rate of asthma in the first population. And there you see that 10 times 1000, 100 divided by 1000 is equal to 1. Likewise, in the second row, we have got 15 times 200 divided by 1000 gives us 3. And so if you follow this logic and continue to work through each of these rows, you get the values that are presented for population 1 and labeled as STD POP1 or standardized values of asthma per 1000 person years for population 1. If we then follow the same logic and reproduce that for population 2 for asthma, we now see for the similar logic 15 times 100 divided by 1000 gives us 1.5. So that's how in STD POP2, which is a standardized values for population 2, we've got 1.5 in the first row. In the second row, likewise, we've got 2.0. The third one, we got 4.5. Now, if you follow this logic, you see that we have got standardized values for that particular population, for population 1 and for population 2. If we then add up the two populations and divide by 1000, we will get standardized values or standardized morbidity rate for each of these individual populations. And because the standard population remains the same, therefore, any importance of the standard population for the standardized rate is not important, but the standardized rates themselves are important for us to make a comparison of the standardized rates of asthma between population 1 and population 2. This is the logic of this. In the right hand panel, we see that presentation of 5 countries for all cases of cancer. So these are age standardized incidence of cancer in a certain time period across or among Australia, New Zealand, Denmark, United States, and Norway. You see that the number of new cases are 212,332 for Australia, 38,000, or a little over 38,000 for New Zealand, uh, almost 49,000 for Denmark, over 200,000 for United States, and for Norway, you can see it's roughly around 40,000. But note the age standardized rates. You can see that although the numbers for new cases vary quite a lot across these countries, you can still see that the age standardized rates are still roughly comparable across these 5 countries. You can see that despite the fact that the United States has got many more times, nearly like 5 more times the number of cases, I mean, more than that, um, of that of Norway, or even for that matter for over Denmark, you can see that its age standardized incidence is still lower. And this information is important for us because if we use age standardized incidence, then we are in a position to make a direct comparison between Australia, New Zealand, Denmark, US, and Norway. So this is a method by which you can make comparisons of the incidence or prevalence or indeed any measure between various countries. Why is this important for environmental epidemiology? Is this that if you get reports and if you can then standardize the values of the prevalence or incidence between a particular region and that of the nation or that of the country, then you are able to find out whether on standardized rates, whether a particular region has got a higher level of problem or greater level of problem than the rest of the country. Or you can make comparisons across and then can make an informed opinion in terms of what action needs to be taken and what needs to be done. So if we go back and think in terms of what we've been doing, we see that this constitutes the completion of first half of the measurements in epidemiology and that of the occurrence and incidence for this module. We had taken a look at prevalence, we had taken a look at incidence, we had taken a look at the at um, how we might think in terms of age specific incidence and prevalence. And then we ended it with a discussion of how might we do age standardization and what is the importance of age standardization for our estimations of the measurements of diseases and health conditions and things like that. So in the next lecture, we will be looking at the at how we can think in terms of the measures of association, and we will be taking a look at relative risk. We're going to take a look at odds ratio. We will be calculating a metric referred to as population attributable risk, and that will pretty much constitute what do we need in terms of to think of in terms of the measurements of association in environmental epidemiology. Okay, so till that time, um, so so we end the lecture here in terms of the measurements of the occurrence of disease, and we will pick it up with measurements of association in the next lecture. Thank you, and thank you for watching this.